Hello dear students, hello, welcome back to the class 9. So in the last class we have started with the exercise number 1.5 and we have completed some of the examples on exercise number 1.5 and remaining one or two examples are there, you have to solve by yourself. Okay, in this video you are going to learn the next concept, that is laws of exponents on real numbers. Next one, that is laws of exponents on real numbers. So this is the last concept of your topic of number system, that is laws of exponents on real numbers. Okay, so this is the last concept, laws of exponents on real numbers. Exponents you have studied in your previous classes. Once again you are going to learn the exponents in the 9th standard also. So here with a new concept, that is laws of exponents on the real numbers. Okay, so here our first law says a raised to m into a raised to n is equals to a raised to mn. So this is the first law, a raised to m into a raised to n is equals to a raised to mn. Second one, you are having a second problem, that is a raised to m whole divided by a raised to n, which is equals to a raised to m minus n. A raised to m divided by a raised to n is equals to a raised to m minus n. Okay, third law you are having as a raised to m whole raised to n is equals to a raised to mn. Okay, so this is the third law, a raised to m whole raised to n is equals to a raised to mn. Fourth one you are having as, that is a raised to 0 or a raised to 0 is always is equals to 1. Okay, and similarly fifth one you are having as, that is law of a into b whole raised to n is equals to a raised to n into b raised to n. A into b whole raised to n is equals to a raised to n into b raised to n. Similarly sixth one you are having as, that is a by b whole raised to minus m, which is equals to b by a plus of m. So this is minus m, when it is taken the reciprocal it becomes as positive m. So these are the 6 laws of exponents on real numbers. So laws of exponents on real numbers. So once again see here, a raised to m into a raised to n is equals to a raised to mn. Similarly a raised to m divided by a raised to n is equals to a raised to m minus n. Similarly a raised to m whole raised to n is equals to a raised to mn. Similarly fourth one, a raised to 0 is equals to 1, and fifth one, a into b whole raised to n is equals to a raised to n into b raised to n. Similarly sixth one, a by b whole raised to minus m, if you take the reciprocal it becomes as positive m. Example, I will choose example for, that is 2 raised to 6 into 2 raised to 3. 2 raised to 6 into 2 raised to 3. A is 2, m is 6 and n is 3, that is 2 raised to 6 plus 3. 2 raised to 6 plus 3, which is 2 raised equals to 6 plus 3, which is equals to 9. Similarly second example, if I take example for second one, that is 2 raised to 3 into 2 raised to 2. So a is 2, m is 3, n is 2, that is a raised to m divided by b raised to n. I write this as 2 raised to 3 minus 2. 3 raised to minus 2, which is 2 raised to 1, which is equals to 2. So this is the second example. Third example you are having as, I will take example for third one, that is a raised to, that is 2 raised to 3 raised to whole raised to 5. So here a is 2, m is 3 and n is 5. A is 2, m is 3, n is 5. So that is 2 into, that is 5 into 3, which is equals to 2 into 5 3s are 15. Okay, so 2 into 5 3s are 15. Similarly a raised to 0, example for a raised to 0 I write 81 whole raised to 0. So anything into 0 is anything raised to 0 is always 1. Okay, similarly if it is 60 raised to 0, it is also 1. Okay, so note down these two problems. Similarly for fifth one, a b whole raised to n is equals to a raised to n into b raised to n. So that is fifth example. For fifth one example, I write 6 raised to, that is I write n which is equals to 2. Okay, so I write 6 in the form of, what I write 6 in the form of 2 into 3. 2 into 3 whole raised to 2, which is equals to, I write 2 raised to 2 into 3 square. Okay, so 2 raised to 2 into 3 square. So this is, I will write in the form of a raised to n into b raised to n. Okay, so this is the fifth example I have given. Sixth one, I'll write sixth example I am going to solve here only. So see here example number 4, sixth law, that is sixth, I will write 2 by 3 which is equals to, I write minus 1. Okay, so 2 by 3 we whole raised to minus n, that is 3 by 2 whole raised to 1. Okay, so 2 by 3, take the reciprocal, right, 3 by 2 minus 1 will become as plus 1. So these are some of the laws and exponents on real numbers, and these are some examples. Go through this video and take this some of the problems and some more examples I am going to solve. So now I am going to solve some more example, that is simplify from your textbook part, that is it is in the form of a raised to m. That is first one 2 raised to 2 by 3 into 2 raised to 1 by 3. This is of the form a raised to m into a raised to n. Okay, is it in the form of a raised to m into a raised to n, means you can write this as a raised to m plus n. So take your first problem. The first problem says that is 2 raised to 2 by 3 into 2 raised to, that is 1 by 3. Okay, so it looks like a raised to m into a raised to n is equals to a raised to m plus n. So this is 2, that is 2 into 2 by 3 plus of 1 by 3. Okay, so 2 raised to, here both the denominators are same, write 3 as it is. So 2 plus 1 which is equals to, now you can write 2 raised to 2 plus 1 which is equals to 3 by 3. 3 by 3 is nothing but 2 raised to 1 which is equals 2 raised to 1 is 2. Okay, similarly first one 2 into 2 by 3 plus 1 by 3, as it is a raised to m plus n, both the denominators contain the same. So 2 plus 1 which is equals to 3, 3 by 3 which is equals to 1, 2 raised to 1 which is equals to 2. Okay, so one more example I am going to solve, that is 7 by 1 by 5 is equals to, so see here 7 by 1 by 5 and 7 by, that is 7 raised to 1 by 3. Okay, so this problem looks like it is a raised to m, okay, whole divided by a raised to n which is equals to a raised to m minus n. Okay, so this problem looks like a raised to m divided by a raised to n which is equals to a raised to m minus n. So just go through this one. 7 raised to 1 by 5 divided by 7 raised to 1 by 3. So just see here, it is 7 raised to 1 by 5 minus of 1 by 3. Okay, so now the LCM will be, that is 5 3s are 15. So 5 3s are 15. So again this is 5 3s are, and this is 3 5s are. So 1 3s are 3 minus of 1 5s are 5. So now 7 raised to 5 minus 3 which is equals to minus 2 by 15. Okay, so minus 2 by 15. First to take the LCM, multiply, so you get 5 minus 3 which is equals to minus 2 by 5. So answer required is 7 raised to minus 2 by 15. Hello dear students, now I am going to solve exercise number 1.6. I am going to solve one problem, and some more 2 problems are there from the first main, second main and third main, that is you have to solve by yourself. And after solving this exercise I complete the first chapter, that is number system. Okay, so see here, this is the last part of your number system. So see here, it is 64 whole raised to 1 by 2. Okay, so it is 64 whole raised, so 64 we know the perfect square is a 64 is a perfect square. You can write this as 64, you can write this as 8 square whole raised to 1 by 2. So if you do 8 square, if you do this 8 into 8, again it is 64. Instead of writing 64, I have written as 8 square, which is equals to whole raised to 1 by 2. Okay, so now see 8, okay, square 2 into 1 by 2. So 8 whole raised to 2 into 1 by 2. So this 2 and this 2 get cancelled. So remaining is 8 raised to 1, which is equals to 8. So this is your required answer. First one, 8, it is 64. 64 is a perfect square. Convert to 8 square. 8 square whole raised to 1 by 2. Remove this 2 outside of the bracket. So 8 whole raised to 2 into 1 by 2. 2 and 2 get cancelled. It is 8 raised to 1. 8 raised to 1 is nothing but it is 8. Okay, so this is the first part. Second part, it is 9 whole raised to 3 by 2. 9 whole raised to 3 by 2. So 9 is the perfect square of 3. So it is 9 is a perfect square, that is you can write this as 3 square 3 by 2. Okay, so again it is 3. If you do 3 into 3, again you will get this as 9. So again it's 3 square. So 3 square is which is equals to 9. So you can write this as 3 2 into 3 by 2. So again this 2 and this 2 get cancelled. So remaining is 3 cube. So again 3 into 3, 9, 3 3s are 9, 9 3s are 27. So this is 27. First is 9. 9 whole raised to 3 by 2. So 9 you can write as 3 square. Okay, and remove this 2 outside of the bracket. 3 whole raised to 2 into 3 by 2. 2 and 2 get cancelled. Remaining is 3 cube. So 3 into 3 into 3. 3 3s are 9. 9 3s are 27. So this is the second one problem. So note down these problems. Next one, last part. That is third example. 2 into 2 by 3 into 2 into 1 by 5. 2 into 1 by 5. 2 into 1 by 3 into 2 into 1 by 5. It looks like the same, that is a raised to m into a raised to n, which is equals to a raised to m plus n. So using this identity you have to solve. So that is 2 into 1 by 3 plus or into 2 raised to 1 by 5. So this you can write as 2 into 1 by 3 plus of 1 by 5. Okay, so this you can write as, take the LCM, that is 2, remaining is 5 3 5s are 15, 3 into 5, 5 into 3, so 5 1s are 5 plus 1 3s are 3. So you will get this as 2 into 8 by 15. So we'll get as 2 into 8 by 15. First thing, use the formula of a raised to m into a raised to n, which is equals to a raised to m plus n. Okay, so now it is 2 into 1 by 3. 2 raised to 1 by 3 into 2 raised to 1 by 5. Okay, so it is 2, that is 2, 1 by 3 plus of 1 by 5. Take 3 and 5 LCM, you will get as 15. Multiply 3 5s are 15, 5 3s are 15, 1 5s are 5 plus of 1 3s are 3. So 5 plus 3, which is equals to 8 by 15. So answer you required is 2 into 8 by 15. Okay, so this is the last part of your exercise 1.6, and this completes your number system of, that is chapter 1. In the next class we will start with one more chapter, that is polynomials. Okay, so all of you go through these videos and solve these examples. On this part, on this first unit, we are going to take, after unit we are going to take one more test on this chapter. So please go through these examples, go through these videos and solve the exercise, and you have to send me on my WhatsApp number. Okay.